The Victorian Planning Authority, in conjunction with the Hobsons Bay City Council, has sanctioned the redevelopment of Altona North Precinct in Victoria from previous industrial use into a mixed-use residential neighbourhood. This required the site located within this area to be assessed and remediated to be suitable for medium-density residential use, as defined in EPA publications. The previous occupation of the site included office, warehouse, underground storage tanks, steel fabrication and reinforcing operations, freight distribution centers, and car parks that facilitated heavy vehicle uses. As a result, contaminants were found pre-remediation, carried out by assessment works by numerous consulting firms. Land contamination within these soils found on site were detected by these assessments, where heavy metals, polycyclic aromatic hydrocarbons, asbestos, and petroleum hydrocarbons were found in the soils and infrastructure, and to have exceeded ecological investigation or health investigation levels, requiring remediation processes. Remediation strategies targeting this ground contamination mainly included demolishing and clearing all buildings and the removal of asphalt fill and underground infrastructure located within the site's boundaries. Soil remediation strategies of stockpiling were targeted towards soils containing exceeded levels of contaminants, which involved blending liquid nutrients and organic compost materials to treat the soils, where post-remediation sampling detailed final soil profiles to satisfy medium-density residential use criteria. During demolition processes, asbestos found within building materials was investigated to exist in the form of cement sheet fragments and millboard that were not significantly damaged and spread throughout the site. These asbestos-containing materials were excavated and disposed of in accordance with contaminated soil guidelines. Further investigation detailed asbestos found within recycled asphalt fill on site, requiring abatement processes of machine sieving followed by validation and inspections of the treated materials. The final site soil contamination levels were below the adopted health investigation levels suitable for residential and commercial use. However, various areas within the site still contained exceedance levels of metals and petroleum hydrocarbons, reaching ecological investigation levels for the site. No remediation work on groundwater located within the site's boundaries was conducted. However, multiple monitoring wells were installed to assess potential contaminants located within the site regarding future uses. Due to the difficult and sparse nature of pollutants within groundwater, various contaminants were detected to have been sourced from on- and off-site locations, to have exceeded quality objective levels for water-dependent ecosystems and species as defined by the State Environmental Planning Policy for waters. Specifically, past site operations such as petroleum storage tanks and industrial uses are deemed to have caused high levels of copper, lead, and cyanide. Various other metals such as chromium, zinc, and nickel are found to exceed objective levels, but are also found to be naturally elevated in the area's geological context, which are consistent with results found nearby. From past assessments and work done on the site, it can be concluded that the groundwater is polluted, but suitable for residential and commercial use, provided that no present and future groundwater extractions occur. Through landfill gas assessments and soil vapor samples, it can also be concluded that the on-site carbon dioxide and methane levels were an acceptably low risk in the context of medium-density residential development and sensitive land use. Further investigation also detailed prior landfill activity as having a minimal effect on gas concentrations and the absence of landfill gas migration. Consequently, this requires at most minimal or no future mitigation measures needed for the site in relation to remediation of soil vapor and ground gas levels. Due to the remnants of various soil and ground contaminants still present on the site but still being deemed fit for use, imported fill should be placed over the site during the initial stages of construction, in addition to off-site soil fill being used for landscape and gardening areas. Groundwater located within the site's boundaries presents a potential need for remediation, where current actions should mandate the site be declared a groundwater quality restricted use zone. Future remediation strategies could include in-situ bioremediation to treat chlorinated and petroleum hydrocarbons on site, in-situ chemical oxidation or reduction, or a pump-and-treat method. However, it should be noted that groundwater remediation methods may not be effective for the site long-term due to the activities nearby and off-site, as well as the costly investment required for these strategies. Frequent future monitoring post-construction should also be implemented to assess the potential long-term contamination levels of groundwater, gas, and soils due to the site's residential occupancy.